Retest review, test 2, problems 9 and 10. Bob invests $7,000 at 9% annual interest. How long in years must Bob wait for his investment to reach $1 million if interest is compounded continuously? For continuously compounded interest, the equation A equals P e to the RT with T in years. Alright, so the P is how much you invested, so Bob is going to invest $7,000. So this would be the P. E is 2.718281828, but there's a button on your calculator for E, so we won't worry about that. R is the interest rate as a decimal, so R is 9%, and our formula would be 0.09. Just take 9 divided by 100, and you'll get 0.09. And then T is how long it's going to take for your money to compound. It says Bob wants to have $1 million, so that million isn't an amount. All right, so they're giving us an amount of money he wants to have, and the question is, how long will it take? So what we're looking for is we're actually trying to find the T. So let's take our numbers that we have and let's plug them into our formula. A is $1 million, so I'll write down 1 million. It's equal to how much he's investing, which is $7,000. Compounded continuously, that'd be e to the power of r, which is 0.09, times t, which we don't know. And what we need to do is solve this equation for the letter t. T is trapped in the exponent, so we've got to get it out of that exponent. But before we do, let's get rid of the 7,000. This is 7,000 times, so I'm going to take each side and divide it by 7,000. So that's going to give me e to the power of 0.09, and then I'm going to put the t like this. That's times t. Over here, I'm going to cross out 3 zeros. It would be 1,000 divided by 7, which 1,000 divided by 7 is going to give me 142.86. And we're trying to solve for t. It's trapped in the exponent position. So to get rid of this t, or to get it out of the exponent position, we have to take a log on each side. And we want to take log base e, which is natural log. So I'm going to take the natural log on each side. And so now I have the natural log of 142.86 equals, natural log of base e will cancel out, and that's going to leave me with 0.09t. And we're solving for t. It's 0.09 times t, so the opposite of multiplying is to divide. So I'm going to divide each side by 0.09. And I will type these two values on the calculator. Natural log of 142.86 divided by 0.09 will give me 55.13 years. So in 55.13 years, Bob will have $1 million in his account. All right, question number 10. Jessica graphed the function y equals 5 to the power of x plus 2 minus 3. What is the domain? What is the range? What is the horizontal asymptote? What is the y-intercept? If you look at this equation, hopefully by now you can recognize it as exponential growth. B is 5, it's greater than 1, it's growth. So just a quick sketch of growth, looks like this. Now, the minus 3 is going to shift the graph down 3 units. Now, it starts out with an asymptote at the x-axis. So I'm going to just move it down 3. So here's our horizontal asymptote. And we're not too concerned with the points, but we know they're going to go left 2 and down 3. So I'm just going to put something over here like this. Just get a general sketch. So what is the domain and the range of a growth? Well, it's always negative infinity to infinity. It's left arrow keeps going left, right arrow keeps going to the right. The range is always the bottom and the top of the graph. At the very bottom is our horizontal asymptote at negative 3, and then the graph keeps going up to infinity. On a growth or decay, the horizontal asymptote is always the k value, which in our situation, k is negative 3, so that's y equals negative 3. And then what is the y-intercept? Well, the y-intercept is a point It's a point who has an x value equal to 0. So if you go to your equation and you set x equal to 0, and then solve for y, that gives you the y-intercept. So 0 plus 2 is 2, so I have 5 squared minus 3. 5 squared is 25. 25 minus 3 will give me 22. So the point 0, 22 is my y-intercept.